Now in example 1, we have to form functions from formulas. What's the area of a circle?
Are you recording yourself?
What's the area of a circle?
Pi times a radius squared.
So there's part A. We have to find the formula for the area of a function according to its radius. Now in B, we have to change the radius to diameter. So how do you do that? Well, we know the diameter is twice the radius.
Yep.
Which means the radius will be the diameter divided by 2. What's going to happen then, we're going to take d over 2 and put it into our original function here and simplify it. So the area will be pi times d over 2 squared. Simplifying even a little further though, that will go like this. And according to your textbook, it'll look just like this. Now for part C, it says write the area of the circle according to its circumference. Well, how do you find circumference of a circle? Well, it would be C equals 2 times pi times r, which means r will equal C divided by 2 pi. Now, so what we're going to do now, we're going to take that C over 2 pi, put it into our area formula. Which means area will be pi times C squared over 4 pi squared. Now what's going to happen to the pi's, Haley?
They're going to cancel.
They're going to cancel, so this pi will cancel with one of these. So it's really going to be C squared over 4 pi. That will be your area. So what we're going to do, because you know that the radius of the spheres are, that only covers half the sphere, and then it also goes to this half. We know that the entire length would be 2r, or the diameter. Well, also we know that the length of one side of the cube is also 2r. And because it's a cube, these are all 2r. So the area of one of the faces would be 2r times 2r, or 4r squared, right? How many faces are in a cube? There's 6 faces in a cube. So because there's 6 faces, it's going to be 6 times 4r squared, which will be 24r squared. That will be your surface area. Now, a square side x inches is cut off from each corner of an 8 by 15 inch piece of cardboard, and the sides are folded up to form an open top box. Write the volume of a box as a function of x. We'll start there. Well, we know that when we cut this out, this side will be 8 minus 2x. This side will be 15 minus 2x. Because x will be here and here. So we're taking an x out of both sides. So our volume function y with respect to x will be our height times our width times our length. So there's part A. Now the next thing we need to talk about is finding the domain of the body. Well, we know domain deals with the x values, and we know volume has to be greater than 0, but it cannot be negative. So our lowest x value from here would be 0. Our lowest x value from the 15 minus 2x would be 7.5. Our highest x value. Our highest x value from 8 minus 2x would be 4. So what we're going to have here, our domain, the lowest it could be is 0. The highest it could be is 4. If you put 7.5 into 8 minus 2x, you'll end up with a negative value, and you don't want that. Now for part C, we have to graph it. Now, a window that we'll use here will go 0 to 4, because that's our domain. Then we'll go 0 to 8 times 15. Now, the reason I'm choosing 8 times 15 is if my x was 0, we'd have a piece of cardboard that's 8 by 15. So that's why my y max is 8 times 15. And if you just put it in your calculator like this, it will actually just give you a value. So when you graph this, you'll get something that looks like this. Now to find the maximum, which is part D, second trace, go down to number 4. Try that again. Now your left bound, you want to find your left bound, would be 0. Now you can type in numbers. Right bound would be 4. So I want to find my maximum from 0 to 4 of my entire domain. Guess, we'll just put a 0 right there. There's your maximum 1.666663 and 90.74. So there's part C and part D. Now, how big should the cutoff squares be in order to produce the box maximum value? It's going to be, well, I guess this is actually part D here. So 1.67 inch by 1.67 inch box. Now, the big thing in this example is we need to start thinking graphically. If you can think of what the graph looks like, then move to the algebraic method, that'll be a lot easier for you. Now, a small satellite dish is packaged with a cardboard cylinder for protection. The parabolic dish is 24 inches in diameter and 6 inches deep, and the diameter of the cardboard cylinder is 12 inches. How tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? So the whole idea is we need to figure out h. Now the way we're going to do that, the general formula for a quadratic function is y equals kx squared. We know we have a y value and we have an x value, so we need to find our k value. Well, if we look at these 2 points here, we have negative 12.6 and 12.6. So we know it's going to be 6 is going to equal k times plus or minus 12 squared, which actually simplified to 6 is equal to 144k, which means k will equal 6 divided by 144, or 1 over 24. Which means our parabola equation, our quadratic equation, be 1 over 24 x squared. Now the next part of this question, how tall must the cylinder be? Well, the big thing that we saw here, the diameter of the cardboard cylinder is 12 inches. So what we want to do, we want to go 6 inches this way and 6 inches this way. So really what we want to do, we want to put 6 in for x squared. And what is 6 squared? 36. Also, divide that by 24. What's 36 divided by 24? It's going to be 1.5. So, this distance here actually is 1.5 inches. So your h value will be 6 minus 1.5, or 4.5 inches. So that's how tall the cylinder must be to fit the middle of the dish and be flush with the top of the dish. It's going to be 4.5 inches tall. Now, example 3a. Suppose that same parabolic dish has a 32-inch diameter and is only 8 inches deep, and the radius of the cardboard cylinder is 8 inches. So what it is, it's a little bit wider and a little bit deeper than the one for 3a. How tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? Pretty much the same type of question. So again, we'll start with y equals kx squared. We know that it'll be 8 equals k times 16 squared, because that's half of 32, which means we'll have 8 is equal to 256k, which will simplify to 8 over 256, that's k, which equal 1 over 32. So our parabola will be 1 over 32 x squared. Now, since the radius of the cardboard cylinder is 8 inches, how tall must the cylinder be to fit in the middle of the dish? Well, what we want to do, up here we put 6, because the diameter of the cardboard cylinder is 12 inches. So we took half of that. Well, the radius of the cardboard cylinder is 8 inches. This one said diameter, so we took 6. This one says radius, so we want to put 8 in. So what we'll end up having is y will be 64 divided by 32, or 2 inches. Now, it is 8 inches deep, so our h value will be 8 minus 2, or 6 inches. So it'll be 6 inches tall. The cylinder must be 6 inches tall to fit in the middle of the dish and be flush with the top.